Another useful feature is filtering rows. It's a very common operation. The basic approach uses a logical filtering. So for example, if I want to use this command, so I want to see those, if a student has got more than a GPA of 3.7, I will use this command. So I will create a column high GPA, which is going to be true for all students in the data frame who has a GPA higher than 3.7. This is created using one condition. You can also put multiple conditions in there. So I want to select students who are older than 20 years and also has a GPA more than 3.5. So student dollar age greater than equals 20 and students dollar GPA greater than 3.5. All those observations, all columns that satisfy these two conditions will be selected in this sub data frame, which is I'm naming as selected. Um, for more complex filtering, the which function is helpful, as shown in the third example over here, where we find students with the highest GPA. Again, the best practices include using clear descriptive names for filtered data frames. So avoid using a name like selected, which later on would be very confusing. Consider using the subset function, which is often a neater way of doing this, and always verify your filtered results. You can also do basic calculations in your data. For column-wise calculations, use functions like mean or sum for specific columns. You can also add calculated columns based on existing data, like converting age to months or normalizing GPA scores. For a quick statistical overview, use the summary to get statistics for each column or string to examine the structure. Key functions for analysis include summary for statistical overview, table for frequency, tables, and aggregate for group-wise computation. When working with multiple columns, apply family functions. Apply family functions is also very useful. Here's an example. First, we identify numeric columns using the supply function. So it will identify all the columns in this data frame that is numeric in nature. And then we will calculate column means for only those numeric columns. You can perform custom calculations across columns using the with function, which provides a cleaner syntax. The most useful apply functions are supply for simplified returns, lapply for list returns, and apply for matrix operations. So why is this important? Now, the reason why it is important is because real world data rarely comes in the exact format you need for analysis. You'll often need to restructure and clean the data before you do anything statistical on it. You need to organize it, sort it, order it, combine information from multiple sources, transform data structure for different analysis, and handle incomplete or messy data systematically. So this is why data manipulation is a very, very important skill. Sorting data frames is essential for data explorations. Here we create an example dataset with student information. For a single column sort, use the order function inside square brackets, like student square bracket order parenthesis student $GPA. For multiple column sorting, provide a multiple arguments to order, as shown in this complex example over here. Now, understanding the order function is key. It returns row positions in sorted order, which we then use to reorder our data frames. Use negative signs before variables for descending order. The function accepts multiple sorting criteria for hierarchical sorting. So if you want a pro tip, For cleaner syntax, use the dplyr arrange function, which offers a more intuitive interface. So you need to install the dplyr this package and then load it before you can use the arrange function. Merging data frames combines data from different sources. Here we have two data frames, academics with students' IDs and GPAs, and details with student IDs and names. An inner join with merge keeps only data frames filling NAs when there is no match. And an outer join, you use merge with all equals true, keeps all rows from both data frames filling NAs when there is no match. So, sorry, I think I messed that up a little. So let me take a step back. There are two types of ways where we can merge data. One is the inner join. Inner join means it will only merge those where there is a match of information. So if I have information on the first three people, and in the second data set, I have information on persons 2, 3, and 4. So if I do an inner join, I will only create a data set with the second and the third person because those are the overlapping sets of information. However, if I want to do an outer merge, if I do an outer merge, then there will be information on all five people across the two data sets, and the missing will be assigned accordingly. Generally, we do an outer merge, like an outer join, and because that's safer, and we just let the NAs exist, which we can deal with later on. And this is again a summary of that. So inner join, you keep only rows that match in both data frames. Left join, keep all rows from left data frame and add NAs for non-matches. Right join keeps all rows from the right data frame and adds NA for non-matches. And full outer join keeps all rows from both data frames and fills with NA where needed. So what I would strongly encourage you to do is create data frames and then try all of them out and see how those results differ. There are two types of format when it comes to data, and the one is the wider format and the other is the longer format. Data reshaping transforms the structure of your data. Here's an example of converting from wide to long format. We start with the wide format where each student has columns for different test scores. Using tidier's gather function, we convert this into a long format where each row represents one student test combination. The key parameters are the key, what to name the new variable column, value, what to name the new value column, and which columns to gather. Why should we reshape data? The reason is different analyses require different data structures. Visualization functions often need long format data where one observation per row. Summary statistics would be easier to calculate with wide format data. Time series analysis have their own specific requirements. The right data shape can make your analysis much simpler. Now let's see the reverse, converting from long to wide. We start with a long format grade data where each row represents one student subject combination. Using the spread function, we convert to wide format where each row represents one student with multiple columns for different subjects. The key parameters are the key, which column contains the variable names, and value, that is which column contains the values. When reshaping data, Keep these important considerations in mind. Always check for duplicate combinations that might cause errors. Again, handle missing values appropriately. And again, always verify the resulting structure matches what you expected.